Hello guys, today we are going to discuss about a process called selective surface hardening. Selective surface hardening. These processes are also called localized heat treatment because only the surface is austenitized and quenched to produce martensite. Selective surface hardening are classified according to the heating source into flame hardening, induction hardening, laser hardening and electron beam heat treating. First one is flame hardening. A high intensity oxyacetylene flame is applied to the selective region. The temperature is raised high enough to be in the region of austenite transformation. The right temperature is determined by the operator based on the experience by watching the color of the steel. The overall heat transfer is limited by the torch and thus the interior never reaches the high temperature. The heated region is quenched to achieve the desired hardness. Tempering can be done in eliminate brittleness. The depth of the hardening can be increased by increasing the heating time. As much as 6.3 mm of the depth can be achieved. In addition, large parts which will not normally fit in a furnace can be heat treated. Next one is induction hardening. In induction hardening, the steel part is placed inside a electrical coil which has alternating current through it. This energizes the steel part and heats it up. Depending on the frequency and amperage, the rate of the heating as well as the depth of the heating can be controlled. Hence, this is well suited for the surface heat treatment. The details of the heat treatment are similar to flame hardening. Next one is laser beam hardening. Laser beam hardening is another variation of flame hardening. A phosphate coating is applied to overall the steel to facilitate absorption of the laser energy. The selected areas of the part are exposed to laser energy. This causes the selected areas to heat. By varying the power of the laser, the depth of the heat absorptions can be controlled. The parts are then quenched and tempered. This process is very precise in applying the heat selectively to the areas that need to be in the heat treated. Further, this process can be run at a high speeds, produces very little distortion. Next one is electron beam hardening. Electron beam hardening is similar to laser beam hardening. The heat source is a beam of high energy electrons. The beam is manipulated using electromagnetic coils. The process can be highly automated but needs to be performed under vacuum condition since the electron beam dissipate easily in air. As in laser beam hardening, the surface can be hardened very precisely both in depth and in location. Next slide is about laser hardened material. Hardened surface layer and the soft and tough core are visible on the slides. Thank you.